All right, everybody, today is Wednesday, February 17th. Go ahead and pause the video, update your table of contents, and name some key attributes of these two functions. All right, so both these two functions we have looked over. We have learned about linear functions, how this point right here, since it's crossing my x and my y axis, it is my x-intercept of 0, 0, and my y-intercept of 0, 0. This graph has a slope. I'm not 100% sure what the slope is because I don't have a bunch of points, but I know it has a slope. The domain is all real numbers. The range is all real numbers. And there's a few attributes. Well, what about exponential? What about that one? Well, I see it has a y-intercept at 0, 1. Based on the equation, I can see the slope. Nope, not the slope, because this is exponential. So its common ratio is 2. And actually, back on the linear equation, based on the equation up here, we can tell that the slope is 1. Let's see. Another attribute of exponential, it has an asymptote of y equals 0. That is why our range is y is greater than 0. Our domain is all real numbers. And we can say this graph represents a growth. So the reason why we review this is because we are going to be talking about another function. This is the last function we're going to talk about here in Algebra 1. This function is called a quadratic function. Okay? You want to write down everything you see about this quadratic function. The quadratic function, the parent function in particular, is f of x equals x squared. The graph is going to look like this here. And you want to make sure you get a sketch of that graph. Now, that U shape, that curve that a quadratic looks like, we call that a parabola. You want to make sure you write down what we call that U shape. We will be using that word a lot. All right, so some other attributes of a quadratic are, number 1, it has a vertex. A vertex is the point where the parabola turns. It's literally its turning point. So with a parabola, it's U-shaped. It's going to keep going, 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 and all of a sudden it's going to turn. And that point where it turns is the vertex. Even if it was an upside down U like this, where it's going up, 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 and then all of a sudden it turns. This right here would be the vertex. The vertex is truly the turning point. Now this vertex can either represent a minimum or a maximum. You want to get a sketch of both of those graphs. Whenever you have a minimum vertex, that point is the lowest point. On the other hand, whenever you have a maximum, the vertex is the highest point. Now, we also have what's called an axis of symmetry. Think back to when we were talking with exponentials, when we said it had an asymptote. It was that invisible dotted line that our exponential curve could not cross. Well, with axis of symmetry, it is another dotted line. This is actually a vertical line where our parabola does cross through this line, and it crosses through at the vertex. And literally, it cuts the graph in half. So right here is my vertex. And then right here is my axis of symmetry. Hold on, spelling that wrong. There we go. Now, your vertex is always going to be written as a point. So for instance here, the vertex is 3, 4. While your axis symmetry is going to be written as an equation. The equation is going to be x equals, what x value are you going through on that line? 3. All right. Now, just like with our linear equations, our quadratics have a y-intercept and an x-intercept, okay? A reminder that an x-intercept is also called a 0, okay? We can call x-intercepts zeros or zeros x-intercepts. They all mean the same thing. Y-intercepts are where the graph crosses the y-axis. X-intercepts or zeros are where we cross the x-axis. Now, you want to sketch these graphs because notice how they're different. First off, looking at their y-intercepts. How many y-intercepts do they all have? Well, this first one has a y-intercept here. And so I see no other one. So this one only has one y-intercept. This one here only has one y-intercept. This last one here only has one y-intercept. So they all have one y-intercept. And that actually applies for all 3 of our functions that we've talked about. However, with the x-intercepts, notice this first graph. We cross the x-axis twice. Once right here, once right here. So both are considered x-intercepts. But on the next one, it only touches once. So there's only one x-intercept. Then lastly, notice on this last one, it never crosses. So there are no x-intercepts. All right, next it brings us to domain and range. Domain, just like all your other equations for linear and exponential, domain is still all real numbers except when it comes to the real world. Your range, on the other hand, is dependent on your graph. In particular, it's depending on your vertex, how high or low it is. So if you have a maximum vertex, in other words, your vertex, your parabola opens down. Your range is going to be y is less than or equal to the y of the vertex. So for instance, on this graph on the right, this one opens down. And so the range is going to be y is less than or equal to that y value of -4. On the other graph, though, it has a minimum vertex. So the range is going to be y is greater than or equal to -16. The reason why we're saying that is because at this vertex, this low point, everything else is going up. Everything else is going up. Everything else is getting bigger. But on the other hand, for the maximum, everything is getting smaller. All right, guys, I'm going to stop the video here with all the attributes. The next video will include examples on it.